Hey guys, welcome to another video. Today we're going to be discussing the sorted squared array problem. So let's look into the problem. We'll do the complexity analysis and then we'll start writing the code. So let's read the problem first of all. Sorted squared array. Write a function that takes in a non-empty array of integers that are sorted in ascending order and return a new array of the same length with the squares of the original integers also sorted in ascending order. All right, so we have a sample input given to us. We open the whiteboard, right? What's our sample input? I'm sorry, I forgot to. Okay, so our sample input is 1, 2, 3, 5, 6, 8, 9. 1, 2, 3, 5, 6, 8, 9, right? That is my sample input. Now we need the square of each number in sorted order. That's what we return, right? Return should be, what does the question say? New array of same length, square of original integers, same length, square of integers in the array and sorted order, right? These three, this looks really bad, huh? The array in the sorted order. So what can we do to achieve that? First of all, same length, right? So one thing we can do is when we can go over each element in this array. So 1 square is 1, 2 square is 4, 3 square is 9, 5 square is 25, 6 36, 8 is 64, 81. These are the squares of each element, right? And this should be in sorted array. So these are already sorted. We don't have to do the sorting on this one. But in case, say, our input is -2, -1, right? In this particular case, what's going to happen is 2 2s are 4 and 1. This is our output. But you can see this is not sorted. So we might have to sort this into 1 comma 1 comma 4, right? And this would be our output. Now let's dive deep into complexity. Okay, so let me write down this one. 1, 2, 3, 5, 6, 8, 9. Now since we have to iterate over each element to calculate the square of all the numbers, our complexity here would be O of n. And then we also have to sort the response. So sorting is going to have a complexity of O of n log n. You can just by heart this one, you can just remember this one. The sorting complexity is always O of n log n, right? So we sort it and we first, go over each element in the array and then we sort it. So our n complexity will be what? O of n plus O of n log n. Or you can also write it as n plus n log n. So my final complexity becomes n log n. Since n log n is greater than n, this is my complexity. And if I use extra space in this program, it could happen that I want to store my result into a separate array. In that case, my space complexity would become O of n. If I store it in the same array, my space complexity would be what? O of 1, right? So this would be my space complexity. let's dive deep into the program. Let's write a program for this one and see how this works. So I already have written the two inputs that I have, sample inputs, and I've called this particular method. So I'm gonna write the code now into this method, right? For you guys to see. So for I to iterate over the whole array, for I is equal to 0, I is less than, you know, array dot length I plus plus. Now, okay, so and square would be what? Square of the two numbers would be array of I multiplied by array of I. If I multiply both the elements, I'll get the square. And then what I can do is in the input array itself, I can do I is equal to square. So I don't have to use extra space, right? And at the end, I can just do arrays dot sort. Uh, so my array is now sorted and then return array, right? Let's run this program and see the response. So my response becomes 1, 4, 9, 25, 36, 64, 81, which is sorted and all are squares. So that's good. Let's check out the response for this one. The response is 1, 4, which is sorted. So that's it for this video. I hope you understood. I'm going to bring you another problem in the next video. Thank you so much for your time. Bye-bye.